What if the most beautiful places you will ever see are not on Earth? They float in the dark between the stars, and they are real. Nebulae that glow like living clouds, newborn worlds forming in bright rings of dust, the ghostly shells of dying suns. Storms rolling across giant planets, galaxies colliding and lighting up the night. We will see space bend light into perfect circles, follow the pull of black holes, and pull back to the vast web that ties the universe together. Every scene you will watch is drawn from real light our telescopes have captured, turned into images we can see and understand. The universe is ready. Since the dawn of our species, there has been a deep and ancient pull. Beneath the same sky, generation after generation has wondered at the mysteries above. Across continents and centuries, people have gathered under the stars, on desert sands, mountain peaks, and city rooftops, drawn together by a sense of wonder and belonging to something vast. It is a feeling shared across all of human history. The night sky has inspired stories. Ancient astronomers traced patterns in the stars, mapping the heavens with careful eyes and steady hands. Their observations became the first calendars, guiding harvests and rituals. We tilt our heads back on a clear, dark night, feeling the same awe as our ancestors, and are met with an endless field of quiet, glittering lights. Each point a sun, each constellation a story passed down through generations. This was our only view of the cosmos, tapestry of stars, and the soft, milky sweep of our own galaxy. In ancient times, great observatories rose from stone and earth. Places like Stonehenge and Jantar Mantar, built to mark the movements of the heavens. It was beautiful. It was mysterious. And it sparked a curiosity that would eventually lead us far beyond the limits of our own eyes. The invention of the telescope changed everything. Suddenly, the moon revealed its craters, Jupiter its moons, and Saturn its rings. The universe became deeper and more complex. Over centuries, our instruments grew more powerful. From hand-drawn sketches to glass photographic plates, and now to digital eyes in space, each advance has revealed more of space than we could see before. We stand on the shoulders of that curiosity, armed with instruments that orbit above our atmosphere, capturing very faint light from far across the universe. The universe revealed by these instruments is more vibrant and more breathtakingly beautiful than we ever could have imagined. Nebulae bloom in color, galaxies collide in slow motion, and stars are born and die in cosmic cycles. This is a journey to see those sights. We will travel across unimaginable distances, witness the birth and death of stars, and float through clouds of gas and dust sculpted by forces of immense power. We will glide past galaxies that swirl like cosmic hurricanes, and watch as they dance and merge in unions that take hundreds of millions of years to unfold. The places we will visit are real. Their beauty is not an artist's fantasy, but the natural expression of the laws of physics playing out on the grandest possible scale. The universe is a gallery, and its artworks are waiting for us. This journey is designed to be a quiet meditation on cosmic beauty, a chance to reflect on our place in the vastness. Our goal is not just to see these wonders, but to understand them. Why does a nebula glow with such intense color? What carves the intricate rings in a disk of dust around a newborn star? Each answer brings new questions, and each discovery deepens the mystery. We are travelers on the ultimate road trip. We will leave behind the familiar blue and white of our home world and venture into the deep, silent dark. The sights ahead are some of the most profound and awe-inspiring visions that humanity has ever witnessed. The universe is calling. Let us go and see what it has to show us. Our journey into the cosmos requires a new way of seeing. The universe is filled with wonders that our eyes alone cannot detect. The human eye, as remarkable as it is limited. We see only a narrow band of the electromagnetic spectrum, what we call visible light. But the cosmos shines in many more colors than we can perceive. Imagine the electromagnetic spectrum as a vast river of energy, flowing from the longest radio waves to the shortest, most energetic gamma rays. Our eyes are sensitive to just a tiny island in this river. If we relied only on our eyes, the universe would appear mostly dark, punctuated by a few points of starlight. But there is so much more to see. To unlock the hidden universe, we have built extraordinary instruments, telescopes on mountaintops, in deserts, and orbiting high above Earth. Each is designed to capture a different kind of light. Radio telescopes, with their giant dishes, listen for the faintest whispers from the cosmos. They reveal cold clouds of hydrogen, the birthplaces of stars, and the echoes of the Big Bang itself. Microwaves, just a bit shorter than radio waves, let us see the afterglow of the universe's birth, the cosmic microwave background, a faint relic from nearly 14 billion years ago. Infrared telescopes peer through cosmic dust, revealing newborn stars and hidden galaxies. They show us the warm glow of planets and the structure of distant nebulae. Visible light, the familiar rainbow, is just a sliver. But even here, telescopes like Hubble have transformed our view, capturing breathtaking images of galaxies, nebulae, and the birth and death of stars. Ultraviolet telescopes reveal the fierce energy of young hot stars and the glowing halos of galaxies. They help us trace the life cycles of stars and the chemistry of the cosmos. X-ray telescopes, like the Chandra Observatory, see the universe's most violent events, colliding neutron stars, black holes devouring matter, and the hot gas in galaxy clusters. Gamma-ray telescopes capture the universe's most extreme explosions, gamma-ray bursts, the death cries of massive stars, and the jets from supermassive black holes. Each wavelength tells a different story. By combining them, we create a richer, more complete portrait of the universe than any single view could provide. Astronomers act as interpreters, translating invisible data into images our eyes can understand. They assign colors to different wavelengths, creating what we call false color images, not to deceive, but to reveal. This process allows us to see the layers of a nebula, the heat of a planet, or the chemical fingerprints of distant worlds. It is a blend of science and art. Consider the famous pillars of creation. In visible light, they appear as towering columns of gas and dust. In infrared, we see newborn stars hidden within. In X-rays, we witness the shock waves of dying stars. Side by side, these images reveal a universe that is dynamic, layered, and alive with energy. Each wavelength is a new window, a new way of seeing. The technology behind these discoveries is a triumph of human ingenuity. Engineers and scientists work together to design, build, and launch telescopes that can survive the harshest environments. From the giant radio dishes of the Very Large Array to the precision mirrors of the James Webb Space Telescope, each observatory is a gateway to a different universe. With every new wavelength we explore, we make new discoveries. We have found planets orbiting distant stars, mapped the structure of galaxies, and traced the history of the universe itself. The translation from data to image is an art form in itself, allowing the hidden beauty of the universe to shine through in all its magnificent glory. It allows us to see the invisible. As we continue our journey, remember, every image you see is a triumph of curiosity, technology, and imagination. The universe is more wondrous than our eyes alone could ever reveal. Our first destination takes us to the places where stars are born. Vast, chaotic, and breathtakingly beautiful clouds of gas and dust known as stellar nurseries. These regions are the cradles of creation, where the raw material of the universe gathers and transforms. These nurseries are immense, the largest stretch for hundreds of light years, containing enough gas and dust to forge millions of suns. Their shapes are sculpted by gravity, turbulence, and the fierce radiation from newborn stars. Within these clouds, gravity acts as the great architect. Over millions of years, it draws together clumps of material, compressing them until the pressure and temperature at their cores ignite the process of nuclear fusion, the birth of a star. But gravity does not work alone. Turbulence stirs the clouds, creating knots and filaments, while shock waves from nearby supernovae can trigger new waves of star formation. Radiation from massive young stars sculpts the clouds into pillars, bubbles, and arcs. Astronomers have spent decades studying these nurseries, using telescopes that see invisible, infrared, and radio light. Each wavelength reveals a different layer of the story: hidden stars, glowing gas, and cold dust. For eons, these molecular clouds drift peacefully, but they are not static. Within their depths, the patient and persistent force of gravity is always at work. The life cycle of a molecular cloud is a cosmic drama. Some clouds are torn apart by the very stars they create, while others survive long enough to birth entire clusters of suns. The interplay of creation and destruction is written in the glowing filaments and dark lanes we see. In some regions, the collapse of a cloud is triggered by the shock wave of a nearby supernova, an explosion that compresses the gas and sets off a chain reaction of star birth. This is cosmic recycling at its grandest scale. As these clumps grow, a tipping point is reached. Gravity overwhelms the cloud's internal pressure, and a slow but inexorable collapse begins. The first stars to ignite flood their surroundings with intense ultraviolet light. This radiation energizes the hydrogen gas, causing it to glow in brilliant reds and pinks. The light also sculpts the clouds, carving out vast cavities and dramatic shapes. The iconic Eagle Nebula, with its towering pillars of creation, is a perfect example. Here, we see the relentless push and pull between gravity and radiation as new stars are born and old structures are eroded away. What makes these clouds glow with such splendor? The light comes from the very stars they are creating. This intense light shines upon the surrounding hydrogen gas, energizing it and causing it to glow. In the Orion Nebula, one of the closest and most studied stellar nurseries, astronomers have discovered protoplanetary disks, tiny solar systems in the making. These discoveries have revolutionized our understanding of how planets form. The Carina Nebula, another stellar nursery, is a region of intense star formation and violent stellar winds. Here, massive stars like Eta Carinae shape the landscape with their energy, creating spectacular bubbles and cliffs of gas. The starlight doesn't just illuminate the clouds, it actively shapes them, carving out vast cavities, sculpting towering pillars, and creating the dramatic, glowing vistas that we are about to explore. Each nebula has its own story. The Trefid Nebula is famous for its dark dust lanes and vivid colors, while the Lagoon Nebula is a turbulent sea of star birth, with newborn stars blasting away their birth clouds. In the heart of these nurseries, astronomers have witnessed jets of material shooting from newborn stars, evidence of the powerful processes at work. These jets can stretch for light years, shaping the surrounding gas and dust. We now journey to the most famous and one of the closest of all stellar nurseries. Welcome to the Orion Nebula. The Orion Nebula is a laboratory for astronomers. Here, discoveries have been made that changed our view of the universe, like the detection of brown dwarfs, failed stars that never ignited, and the first glimpses of planetary systems in formation. Located about 1,300 light-years away, this is a vast, bustling metropolis of star formation, where hundreds of young stars have recently burst into existence. At the heart of the nebula lies a tight cluster of brilliant, hot, young stars known as the trapezium. These are the newborns. They are the power source for the entire region. Their radiation is ferocious, a stellar wind of particles and light that is blasting away the surrounding gas and dust, carving out the immense bowl-shaped cavity that we see. The colors here tell a rich story. The dominant red glow comes from ionized hydrogen. We also see delicate veils of blue and violet. The greenish tints are the signature of superheated oxygen atoms. Deeper within the nebula, hidden from view, infrared telescopes can pierce through the obscuring dust to reveal these stellar embryos, each one cocooned within its own small, dense knot of gas. The discovery of these hidden stars was a triumph of technology and curiosity. With each new telescope, we peel back another layer of the cosmic story, revealing the secrets of star birth. From the broad vista of Orion, we now travel deeper into space to a small but iconic region within the larger Eagle Nebula. Here we find one of the most celebrated astronomical sights ever captured, the Pillars of Creation. These towering columns of gas and dust are both a nursery and a graveyard, as new stars form while others are destroyed by intense radiation. These pillars are not permanent structures. They are ephemeral, destined to be destroyed. They are being eroded and evaporated by the intense ultraviolet radiation from a nearby cluster of massive young hot stars. The detailed textures on the surfaces of the pillars show us this destructive process in action. We can see wisps of gas peeling off the tops and sides, a slow unraveling that will eventually erase these cosmic sculptures. But within the pillars, gravity is winning in some places. When the James Webb Space Telescope imaged this region, it revealed a startling number of newborn stars, seen as brilliant red points of light. These discoveries remind us that even in the midst of destruction, creation continues. The universe is always renewing itself, forging new stars from the ashes of the old. These images prove that star formation is actively happening inside these incredible structures, even as they are being destroyed from the outside. Our next stop takes us far into the southern sky, to a stellar nursery that dwarfs even the great Orion Nebula. This is the Carina Nebula, a region of wild beauty and violent change. One of the most spectacular features within Carina is a formation nicknamed the Cosmic Cliffs. This is the jagged, soaring edge of a giant molecular cloud. The Carina Nebula is also home to one of the most unstable and famous stars in our galaxy, Eta Carina. In the 1840s, it underwent a massive eruption that now forms a distinctive two-lobed cloud around it. Eta Carinae is destined to explode as a supernova, an event that will send a final, devastating shockwave through the entire nebula. As we drift through these stellar nurseries, we see an incredible diversity of shapes. the pillars, cavities, bubbles, and cliffs, all sculpted by the same fundamental forces of gravity, radiation, and turbulence. Ultimately, every stellar nursery is a temporary spectacle. Over a few million years, the combined energy from the young stars will blow away all the remaining gas and dust. All that will be left is a brilliant open cluster of young stars adrift in space, their gaseous cradle gone forever. The story of stellar nurseries is the story of cosmic evolution. Each new generation of stars enriches the galaxy with heavier elements, seeding the clouds that will one day form new stars, planets, and perhaps life itself. As we leave these nurseries behind, we carry with us a sense of wonder at the beauty and complexity of the universe. The journey of a star, from cloud to light, is a reminder that creation and transformation are woven into the very fabric of the cosmos. As the chaotic violence of the stellar nursery subsides and a young star emerges from its gaseous cocoon, a new and more orderly phase of creation begins. The swirling clouds of gas and dust that once hid the newborn star now begin to settle, and a remarkable transformation unfolds. Gravity draws the remaining material into a vast, rotating disk encircling the star's equator. This is the protoplanetary disk, a cosmic construction zone where planets will one day take shape. Due to the conservation of angular momentum, the remaining material does not simply fall into the star. Instead, it flattens out into a vast, rotating disk that encircles the star's equator. Within this disk, countless dust grains begin to collide and stick together. Over thousands of years, these tiny particles grow into pebbles, then boulders, and eventually into kilometer-sized planetesimals, the building blocks of planets. This is a protoplanetary disk, and it is the birthplace of planets. It is the leftover raw material from which new worlds will be built. As these planetesimals grow, their gravity attracts more material, leading to runaway growth. Some will become the rocky cores of terrestrial planets, while others will gather thick envelopes of gas, becoming gas giants. When we view these disks with the right instruments, we see something remarkable. They are filled with intricate structures, bright rings, dark gaps, and sweeping spiral arms. These features are not random. Each ring and gap is a clue, evidence of young planets carving paths through the disk, shaping their environment as they orbit the star. These features are not random. They are signposts, direct evidence of unseen planets forming within the disk. Each gap is likely a path being cleared by a young, growing protoplanet. Astronomers use powerful telescopes, both on the ground and in space, to study these disks in detail. Arrays like ALMA in Chile and the Hubble and James Webb Space Telescopes have revolutionized our understanding of planet formation. In different wavelengths, radio, infrared, and visible, scientists can peer through the dust and gas, revealing the hidden structures within these disks. These images are like cosmic sonograms, giving us our first direct look at the process of planet formation as it happens. A snapshot of what our own solar system must have looked like. In some disks, astronomers have detected the chemical fingerprints of water, organic molecules, and even the precursors to life. These discoveries hint at the potential for habitable worlds forming far beyond our solar system. To truly appreciate the wonder of these planet-forming disks, we travel 450 light-years away to a star named H.L. Tauri. The image of H.L. Tauri's disk, captured by ALMA, stunned astronomers with its clarity. It showed a series of bright rings and dark gaps, direct evidence of planets forming in real time. In 2014, the Atacama Large Meter Submillimeter Array captured an image of the disk surrounding this star that stunned the astronomical world. Since then, astronomers have found dozens of disks with similar features, each one a unique laboratory for studying the birth of planets. The image from ALMA shows the disk around H.L. Tauri as a series of beautifully concentric, bright rings of dust, separated by dark, well-defined gaps. The symmetry is breathtaking. Each disk tells a different story. Some are massive and bright, others faint and wispy. Some show clear signs of planet formation, while others remain mysterious and chaotic. The immediate and most compelling explanation is that there are planets forming in those gaps. Each dark lane is the orbit of a nascent world. The diversity of planetary systems is astonishing. Some stars host tightly packed systems of rocky worlds, while others have giant planets orbiting far from their suns. There are even planets that orbit two stars, like the fictional worlds of science fiction. What makes the HL Tauri image so profound is the age of the system. It told us that planet formation starts much earlier and proceeds much faster than we ever imagined. The discovery of thousands of exoplanets has revealed that our solar system is just one of countless possible outcomes. Some exoplanets are larger than Jupiter, orbiting scorchingly close to their stars. Others are small, rocky worlds in the habitable zone. Looking at this image, we are seeing a blueprint for a solar system, their gravitational signatures carved into the very structure of the disk. By studying the chemistry of these disks, astronomers can trace the origins of water and organic molecules, key ingredients for life as we know it. The story of planet formation is also the story of the potential for life elsewhere in the universe. For a different perspective, we return to the turbulent heart of the Orion Nebula. Here, the environment is far more hostile. In regions like Orion, intense ultraviolet radiation from massive stars sculpts and erodes the disks, creating dramatic shapes and sometimes halting planet formation altogether. These objects are called protoplanetary disks, or proplyds for short. They are being photo-evaporated by the nearby massive stars. The intense radiation heats the outer layers of the disk, causing the gas to glow and stream away. Yet, even in these harsh conditions, some disks survive long enough for planets to form. The resilience of these cosmic nurseries is a testament to the tenacity of creation. It is a race against time. Can the planets form before the disk is completely destroyed? We are seeing cosmic survivors, tiny pockets of creation holding out against an overwhelming force of destruction. The study of these disks is not just about distant worlds. It is a window into our own past, a way to reconstruct the history of our solar system and understand how Earth and its neighbors came to be. Even in this harsh environment, the disks are dense enough to shield their inner regions, where the process of planet building can continue in relative safety. As astronomers continue to refine their techniques, new discoveries are made every year. The next generation of telescopes will reveal even more about the hidden processes that shape planetary systems. The images of disks like HL Tauri and the proplyds in Orion show us that the formation of planets is a natural and perhaps inevitable consequence of the formation of stars. The more we look, the more we realize that planets are everywhere. The universe is filled with worlds, some familiar, some utterly alien, each one a product of the same cosmic processes that shaped our own home. It begins with microscopic dust grains, colliding and sticking together. These grow into pebbles, then boulders, and then kilometer-sized objects called planetesimals. Over millions of years, these planetesimals collide and merge, sometimes violently, sometimes gently, until a planetary system emerges from the chaos. This blueprint also helps explain the architecture of our own solar system. This is where smaller rocky planets like Earth and Mars form. Farther out, ice can condense, allowing for the rapid growth of giant cores, creating gas giants like Jupiter and Saturn. The story of planet formation is ongoing. Every new discovery adds a piece to the puzzle, bringing us closer to understanding our place in the cosmos. Observing these distant, young solar systems is like finding a photograph of our own parents as infants, helping us reconstruct our own history. and understand the chain of events that transformed a simple cloud of interstellar dust into the vibrant, living planet we inhabit today. As we gaze at these distant disks and the worlds they are forming, we are reminded that the story of creation is universal. The same forces that shaped our solar system are at work across the galaxy, building new worlds and new possibilities. As we leave behind the tranquil disks where planets are born, we journey toward some of the universe's most dramatic and violent events, supernovae. These colossal explosions mark the deaths of massive stars, yet they are far from simple endings. Instead, they are cosmic rebirths, reshaping the galaxy and setting the stage for future generations of stars and planets. Let's begin with the Crab Nebula, an intricate tapestry of filaments and glowing gas, located 6,500 light-years away in the constellation Taurus. Here, the aftermath of a stellar explosion, witnessed on Earth nearly 1,000 years ago, is still racing outward. The nebula's delicate, thread-like structures are the tangled remains of a once massive star. Each color in this cosmic web tells a chemical story: red for hydrogen, green for oxygen, blue for sulfur. These hues reveal the element-rich debris hurled into space at unimaginable speeds, enriching the galaxy with the building blocks for new worlds. Moving on to the Vela supernova remnant, we see shock fronts, waves of energy, plowing through space at thousands of kilometers per second. These shock waves compress and heat the gas, lighting it up in X-rays and radio waves. The glowing filaments are not just beautiful, they are evidence of the incredible temperatures and energies unleashed in the explosion. Here, the blast's force sculpts the interstellar medium, stirring up clouds that may one day collapse to form new stars. Cassiopeia A, a supernova remnant just 11,000 light-years from Earth, offers another spectacular view. In X-ray images, we see a brilliant halo of hot gas, glowing in shades of blue and purple. This is where the shockwave from the explosion is still heating the surrounding material to millions of degrees. Embedded within the remnant are knots and clumps, each rich in different elements: silicon, iron, calcium, created in the heart of the dying star. These heavy elements are essential for forming rocky planets, atmospheres, and even the chemistry of life itself. Supernova are not just destructive, they are creative. With each blast, they seed the galaxy with heavy elements, mixing and enriching the interstellar clouds that will give rise to future stars and planets. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the hearts of ancient stars and scattered by supernovae like these. As we gaze upon these remnants, Crab, Vela, Cassiopeia, we see not just the echoes of cosmic destruction, but the seeds of new beginnings. Each glowing filament, each racing shock front, is a reminder that the universe is constantly recycling, turning endings into opportunities for creation. In this way, the story of supernovae connects us, across time and space, to the very heart of the cosmos. As the remnants of ancient stars drift and mingle, the galaxy gives rise to new wonders. Stellar clusters, where stars are born and bound together in cosmic communities. Let's begin with one of the sky's most enchanting jewels, the Pleiades, or Seven Sisters. Through the cold darkness, their blue shimmer pierces the night, a cluster of young hot stars wrapped in wisps of interstellar dust. This dust scatters their brilliant blue light, painting delicate halos around each sun and illuminating the space between them. The Pleiades are an open cluster, loose, youthful, and vibrant. Stars here are only a few 100 million years old, still racing away from their birthplace, their bonds easily broken by the tides of the galaxy. But not all clusters are so young or so loosely held. Journey now to the ancient heart of our galaxy, where globular clusters like Omega Centauri and 47 Tucanae dwell. These are dense, spherical collections of hundreds of thousands, even millions of stars, packed so tightly that in their crowded cores, night never truly falls. Each globular cluster is a living fossil, nearly as old as the Milky Way itself, holding secrets from the dawn of time. Their stars glow in a spectrum of colors: cool red giants, hot blue stragglers, and the golden light of aged suns, woven together in a celestial tapestry. Here, the sheer number of stars dazzles the imagination. In a single globular cluster, you could count more suns than in entire swaths of the night sky. The interplay of starlight and dust creates a spectacle of color and brilliance, a cosmic celebration that stretches for dozens of light years. Whether open and fleeting, like the Pleiades, or ancient and enduring, like Omega Centauri and 47 Tucanae, star clusters are gatherings of creation and memory. They remind us that stars, like people, often begin their journeys together, sharing their light, shaping their surroundings, and eventually drifting apart to illuminate the galaxy in their own way. In every cluster, we see beauty born from unity and the endless creativity of the cosmos. From the bustling gatherings of star clusters, we journey outward into the majestic arms of spiral galaxies, where cosmic artistry reaches its grandest scale. Here, vast swirls of stars, dust, and glowing gas paint the universe with patterns both beautiful and profound. Let's glide first through the iconic Whirlpool Galaxy, M51. Its sweeping arms unfurl like a celestial dance, traced by dark dust lanes that wind through luminous clouds. These dust lanes are the birthplaces of stars, marking the spiral's path with intricate shadows and light. Along the arms, brilliant knots blaze, nurseries where new stars ignite and illuminate their surroundings, setting the galaxy aglow with youthful energy. At the heart lies a glowing bulge, a densely packed core of ancient stars, anchoring the spiral in a golden embrace. Now, drift toward the Pinwheel Galaxy, M101. Its grand open arms spiral gracefully outward, adorned with clusters of hot blue stars and streaks of interstellar dust. Each arm is a highway for star formation, channeling gas into dense pockets where gravity forges new suns. As the spiral winds, it shapes the destiny of everything within, guiding clouds, stars, and even planets along its cosmic currents. Spiral galaxies like M51 and M101 are favorites for astronomers and stargazers alike. Their wide, open structures reveal the galaxy's architecture in stunning detail, making them ideal subjects for wide-field images. The interplay of dust lanes, star-forming knots, and radiant cores creates scenes of breathtaking complexity and color. But these spirals are more than just beautiful. They are engines of creation. Their arms are not static. They are waves of density, guiding gas and dust into regions ripe for starbirth. As the galaxy spins, these waves sweep through, lighting up the arms with clusters of newborn stars that shine for millions of years before drifting away. In every spiral, we witness the universe's grand design, order emerging from chaos, beauty born from the interplay of gravity and light. These cosmic pinwheels remind us that even on the largest scales, the universe is alive with motion, creativity, and endless wonder. Beyond the elegant spirals lies a wilder universe, where galaxies defy convention and cosmic encounters sculpt astonishing new forms. First, behold the Sombrero Galaxy. Its luminous, bulbous core is wrapped in a bright, perfect ring of dust, like a celestial hat adrift in space. This striking silhouette is the result of a dense disk seen nearly edge-on, its dust lane casting a shadow across the galaxy's radiant heart. Here, ancient stars cluster in the bulge, while the ring's dust and gas nurture new generations, blending the past and future in a single, dazzling frame. Now, journey to the Cartwheel Galaxy, a cosmic ripple frozen in time. Once a spiral, it was struck by a smaller companion, sending shockwaves outward. The result, a glowing ring of intense star formation, expanding like ripples on a pond. Blue clusters blaze where the waves ignite clouds of gas, and pink nebulae bloom in the aftermath. The cartwheel's unique shape is a testament to how dramatic events can birth unexpected beauty in the cosmos. Finally, witness the antennae galaxies, a spectacular collision in progress. Two star-filled giants are locked in a slow-motion embrace, their arms twisted into sweeping tidal tails. Where they collide, vast clouds of gas crash together, triggering furious bursts of starbirth. Brilliant blue clusters and rosy nebulae light up the chaos, painting the scene with the colors of creation. Though violent, these mergers are not endings, but beginnings, scattering seeds for future stars and reshaping galaxies anew. In these odd and interacting galaxies, we see that the universe is not always orderly. Sometimes, cosmic collisions and close encounters spark the brightest lights and the most unexpected wonders. Each encounter is a reminder, in the universe, even chaos can create beauty. In the vast darkness between galaxies, gravity itself becomes an artist. Welcome to the realm of gravitational lenses, where the universe's largest objects bend the very fabric of space, warping the light from galaxies far beyond. Imagine a distant galaxy sending its light across billions of years. If that light passes near a massive cluster, the immense gravity acts like a cosmic magnifying glass, curving and focusing the rays. To our telescopes, these hidden galaxies appear as stretched arcs, luminous smears, or even perfect circles. Einstein rings, each one a signature of space, being twisted by invisible forces. These natural lenses reveal galaxies too faint or distant to see otherwise, granting us glimpses into the earliest chapters of the cosmos. But gravitational lensing is more than a spectacular visual effect. By studying the shapes and brightness of these arcs and rings, astronomers can measure the weight of entire galaxy clusters, including mysterious, invisible dark matter. The more distorted the light, the more mass there is, even if we can't see it directly. In this cosmic funhouse mirror, gravity lets us peer deeper, see farther, and weigh the unseen. Every arc and ring is a message from the hidden universe, amplified by the silent strength of gravity itself. In the heart of our galaxy, a silent giant waits. This is Sagittarius A, a supermassive black hole, an object so dense that not even light can escape its grasp. Black holes are the ultimate enigma, invisible, yet their presence is revealed by the chaos they unleash around them. Surrounding each black hole is an accretion disk, a swirling maelstrom of superheated gas and dust spiraling ever closer to oblivion. As matter falls inward, it heats up, glowing brightly in X-rays and radio waves, painting a portrait of violent beauty against the darkness. But the black hole itself remains unseen. All we can glimpse is its shadow, a silhouette carved into the glowing disk, where gravity bends light into a perfect ring. This shadow, captured for the first time by the Event Horizon Telescope, offers proof of Einstein's boldest predictions. Yet black holes are not always silent. In distant galaxies, some black holes awaken, launching colossal jets of energy that pierce the darkness for thousands of light years. These jets, seen by radio telescopes as glowing threads across the cosmos, carry away matter and energy, shaping the evolution of entire galaxies. By combining images from radio arrays, X-ray observatories, and infrared telescopes, we piece together the story. Black holes may be invisible, but their influence is written across the universe in arcs of light, rivers of plasma, and the faint echo of gravity itself. In this cosmic ballet, the darkest objects become the brightest beacons, reminding us that even in the deepest shadows there is light and information to be found. Subscribe to join us on more cosmic journeys and uncover the wonders of space with every new documentary. Don't miss our next voyage into the great mysteries of the universe. Each space documentary is crafted to inspire curiosity and bring the latest scientific discoveries to life. Be part of our growing community of explorers, dreamers, and lifelong learners. Subscribe now and keep reaching for the stars with us.